Let's jump into this. We're going to go over how to find the indefinite integral of a to the x, or a to the u. So I'm going to give you the formulas first, and then we're going to talk about why they make sense. So the indefinite integral of a to the x is going to be a to the x, but you've got a 1 over ln a, and of course you have plus c. And in general, this is going to be pretty much the same, 1 over ln a times a to the u plus c. Okay, so why does this make sense? Well, we know that the derivative of a to the u is equal to a to the u times u prime times ln a. Well, if I'm taking the antiderivative of a to the u and there's no ln a there, when we take a derivative of our answer, an ln a is going to come out. So we've got 1 over ln a to balance that ln a that's coming out of there. So when I take a derivative of this, you'll have an a to the u times ln a. You've got the u prime as well. And now the ln a's will cancel, leaving you with a to the u prime, or a to the u du. So that's why we need that 1 over ln a. It's basically almost like u substitution. Okay, so how do we take the integral of this? Got to use our formula. So this is going to be equal to still 5 to the x times 1 over ln 5, or just over ln 5, however you want to write that, plus c. That's it. Now this one, a little u substitution is involved here. I'm going to let u equal to 4x squared, because its derivative is going to involve an x, so looks good. That's going to be du equals normal e to the, or normal like e to the u stuff, but in this case it's 2 to the u. So u substitution gives us 8x dx. So we don't have an 8x, so I'm going to put an 8 here, and I'll divide by 1/8, or multiply by 1/8 that is. So I'll get 1/8, the antiderivative, 8x dx is du. So I get du, and then I get 2 to the u. So now what we have is a simple formula template to follow. That's to be 1/8 times 1 over ln of a being 2, so it's ln of 2, times 2 to the u, plus c, and we'll plug back in for u. So we got 1 over 8 ln 2 times 2 to the 4x squared, and then that's plus c. Done. That's all there is to it. That's all I wanted to go over with this. Just show you how to integrate when you have a to the u, and it's not bad. All right, I will see you in the exercises. Until then, be well and peace.